Okay, good morning.
Good morning.
So let's get started. I've got quite a bit of stuff to get through here. My name is Paul McCullough, and I'm the creator of the pbxt storage engine. Just in case you were wondering, I wasn't invited to the battle of the egos because I don't have an ego. So this is an overview of the talk today and the topics that I'll be covering. First of all, I'll give you a bit of background about the engine and about us. And then we'll go through the design and structure of pbxt. I'll be talking a bit about my experiences with the implementation and testing of the storage engine. We'll look at a bit at the performance. And most important for us, what we plan for in the future. And then there'll be a bit of time for questions. But hopefully we can get through quick enough. So our company is Snap Innovation, and our main business is sales and support integration of an electronic publishing system, which is database centric. We also do print to web, so we take the published data and we publish on the web for our customers. We automate that all together. The company was founded 11 years ago. Currently has 28 employees. And we're based in Hamburg, Germany, so if you're in the area, please make sure you look us up. So the Primebase database itself was originally developed for the publishing market, and that's where it is still very strong today. So there's a number of publishing systems actually based on the database. K4 is one of them. And the database itself is strong in features like block support, full text searching, and replication. Those are the features that are particularly important to our customers. So to state the obvious, pbxt, for those who don't already know, is a transactional storage engine for MySQL. So this is an interesting point. It was actually designed and created specifically for MySQL. It's not retrofitted like a lot of the other engines today. So that has actually given me an advantage in the, I think it's given me an advantage in the speed of the development. It's been released under GPL, and it's hosted on sourceforge.net. So why did we do it? The most important reasons. Well, first of all, we have a particular customer need which we're wanting to meet. So the current Primebase technology has specific limitations, and we want to, XT is designed to overcome these limitations in scalability. And of course, we're also thinking long-term. Open source, we believe, allows small companies like us to really compete, and that's due to the community effect. So you've got a lot of small companies and individuals that each get together and do what they do best, and for some of them it enables them to compete with larger, more established companies. So it also gives us an opportunity to apply our experience in a particular area, and I'll be talking about this a bit later. This is scalable blob streaming, a new project which we're pretty excited about here in the MySQL community. So let's just look briefly at the history of pbxt. Now, almost 2 years now, I started planning, had some ideas, and we looked at a proof of concept. The first actual implementation was for MySQL 4.1, beginning in November 2005. About 5 months later, I made the first source code release. Then I threw it all away and started again. And 3 months later, I released what's called the restructured implementation. That's actually a joke. But I changed a lot. By the way, how many of you have read my white paper? Okay, don't worry, it won't be boring because a heck of a lot has changed since then. So. Right, the first beta release was in September 2006. And a few months later, we released the very first standalone pluggable storage engine for MySQL, so I'm quite proud of that being the first there. Somebody can correct me if that's not the case. This year I completed foreign key support and most recently the Windows version. So let's look at the most important design aspects of pbxt. The design is unconventional, so I think it's pretty interesting. But first of all, something that is quite conventional, it's a pure MVCC implementation, does multi-version concurrency control, identical to Falcon in that sense. Every transaction gets a complete snapshot of the database when it begins. It's file per table based, like MyExam. And it uses a write once, write through strategy, which basically means it's writing as fast and as directly to the disk. Write once in this case means that it actually only writes the database, and in the transaction log it puts a reference to the page that is written in the database. So it doesn't write the actual page into the transaction log. So another strategy is never to update in place, always to create a new record. So when pbxt does an update, it creates a new record, and later it will delete the old one. Also important to notice that the variable length data in pbxt is always written in one block and sequentially. So reading and writing of variable length data is always sequential. So it doesn't use blocking in the traditional sense. Also quite unconventional, it doesn't actually do recovery. When pbxt starts up, it just kicks off the garbage collection, and I'll be speaking a little bit more about that in a bit. So if you want to actually put pbxt in a box and say, where do I fit it in all this, all these engines, amongst all these engines, then I'd say, think of it somewhere between MyExam and NRDB. Particularly in the design, it's very similar to MyExam, but it's transactional. So we've got performance that is somewhere in between MyExam and NRDB, and that also applies currently to the durability of the engine. So looking at the design now from the top down, the table data structure, quite simply, a table consists of a number of rows, and each row has a unique ID, which is also the row ID. So each record has a list, each row has a list of records, which I also call variations, and these are the various versions of that record. So it's a list. The latest version of the record is at the head of the list, and then as you go down the list, you get to older and older records, or older and older versions of the row. This is classic MVCC really. Right, so in each variation, transaction ID is stored of the transaction that created that variation of the record of the row. And now this is important for pbxt. Each variation is divided into two components. One is a fixed length component, and one is a variable length component. Both of these components contain data. The variable length component can also be seen as an overflow area. So if your data doesn't fit into the fixed block, then it overflows into a variable length record. So the variable length record is actually optional. So how does MVCC work in pbxt? Well, quite simply, all of the variations, and all the variations are stored on disk. Each of them is indexed individually. So we don't actually have a unique index, but pbxt creates the illusion of a unique index for those indexes that have been declared as unique. So Now, whether pbxt is doing an index scan or a sequential scan, it always examines all variations that match the given criteria. And it's the job of the transaction to then decide whether the variation is visible or not. And it does it based on two criteria. The first is, has this variation been committed before I started? That's the symbol one. So it examines the transaction ID in the variation to be able to determine this. But not only that, it's got to be the first visible variation for that transaction on the list of variations for that particular row. So it's actually got to go to the variation list head and trace down to see if it's actually the first visible version. And it mostly is, so this actual test is not that inefficient. So now that was from the top down. Now we're going from the bottom up again. Let's look at the files that are created by pbxt when you create a table. So I've got a simple example here. This notes table has variable length record, and that's determined by the varchar, the varchar text field of 500. And if I execute these two statements, the create table and the insert, and look in the directory of the database, MySQL, then I'll see quite a number of files already. 5 of those files relate directly to the table. As you can see, they have the table name at the front. And at the bottom, these two here are the transaction logs created by XT for that database, first of all. Well, the DB belongs to MySQL. And now looking at the table, the files that belong to the table, familiar to everybody will be the .frm file, which is contains the structure of the table, is created by MySQL. At the top is the .xtr file, and it has a name which is, consists of two components. The first component is the obviously the name of the table, and the second component is an ID created by pbxt. So pbxt issues a unique ID to every single table that it creates, and it stores it in the table, in the XTR file table name there. That's just a number which is incremented. And then if we go down the list, the .xtd file is very similar to, you can compare it to the MyExam data file. The .xti file contains all the indexes of the table, just in the same way as the MyExam index file contains the indexes. And then the .xtl file is the interesting one. That's called a data log file. It's also got a number next to it because there can be more than one of these files per table. Currently, it's limited to 4. And that number is simply the log number, the number off the underscore. And that can be a number which ranges from 0 to 3. So I'm quite proud of this diagram. It illustrates now the relationship between those tables, starting again at the top, between the files. Sorry. Starting at the top, we have the XTR file, call it the row pointer file. It's actually a row index file. So it's a direct index on the row ID for the rows in the table. And each index entry is very small, only 8 bytes, and contains a pointer to the head of the variation list for that row. So if you're following the link then, if you follow this link then down, it references the handle data file. That's the XTD file, the data file, simply. But I call it the handle data file because the records, as I said, these contain the fixed component of the variations of the record. And each component consists of itself then 2 pieces, as is labeled here. The one is a handle and the other is a data component. And the handle itself has 2 pointers. The first pointer references the overflow area, which is the variable length component of the record, which is stored in the SQL files or the data log file. And the second pointer is simply a previous link on the variation list. So for this record, this is the most recent variation, and as we follow this link, we're going back in time. And then, as I said, you've got a fixed length component of data, and if that's not enough, then it overflows into the variable length component there. And these, in the data log file, these components are always written sequentially, one after the other, no matter how much data in that row.
Question.
Yeah.
You want us to ask interactive or wait for the end?
Beg your pardon?
Can we ask now? Or?
I think just short questions, because I've got a lot of stuff to get through. If possible, to the end, I hope we'll have about 10 minutes. Maybe you could note the question and come over, or?
That's fine. I'll ask the question and up to you to answer it now. Okay. How do you maintain these different flavors of records for the same row, for the same row? At some point in time, you want to delete some of them, you don't need some of them, right?
How do I maintain them?
Right.
Actually, I think we're going to get to this right now, because this is garbage collection.
I have a small question. What is about the XCR, the holes in this file?
What about the holes in the file?
Yeah, about the XCR file.
Yeah, it can be, if you do delete rows, then holes develop, but because of the way it's managed quite simply. It's fixed length records which are managed quite simply, so anything that is freed goes onto a free list, and the next time a record is allocated is taken from the free list instead of adding it to the end.
Oh.
Both files, both the XTD and the XCR files are managed in that manner. Okay, so garbage collection. Just some general comments to garbage collection. It's a dirty word, really. All engines do garbage collection. It involves basically identifying and removing, reclaiming unused space. So every engine has actually got to do this. So it's just a question about how they're going to do it. Are they doing it on the fly, or are they doing it in the background? Now, I don't want to confuse you. We shouldn't confuse just because of the term garbage collection in pbxt with that we know in a virtual machine, which uses a classic mark and sweep algorithm, which is very time consuming and often requires setting locks. So in pbxt, there's no need to search for the garbage. The garbage can be easily identified, and it also does the whole job without setting any locks. That's important, obviously. No locks, on the tables. The garbage collection in pbxt is done by two low priority background threads, which I call the sweeper and the compactor, and they do similar jobs to things like in Falcon called Gopher and so on. So I'm not very imaginative with my names, but anyway. It's important is what they actually do. So the sweeper, the job of the sweeper is to, after a transaction has ended, the sweeper scans the transaction log and identifies the variations that were written by that transaction. So if the transaction was rolled back, then it simply removes the variations, and it's done. And if the transaction was committed, then it removes those variations that are no longer visible because of this. And now, important, if any of those variations contain a variable length component in the data log file, then it marks that component in the data log file as deleted and as garbage, basically, and it does that for the next thread, which is the compactor. So this is the way that works. All of the data logs that you see there, as I said, there can be more than one per table. They have in the header a garbage count. So the compactor monitors the levels of the garbage in each of the data log files, and when it reaches a certain threshold, which is currently 50%, but that I'm going to make adjustable so that you can clean out really if you want to. When it reaches this level, then it starts to compact the file. Compaction algorithm is fairly straightforward. It simply scans the data log byte for byte and identifies those records that are still referenced from the handle data file. And those records that are referenced are then copied to a new data log file, and the reference is updated. And when it's done, it deletes the old log. So in this way, it actually just it reclaims that space that was garbage without locking the file or the table. So this is overview of all the components of the pbxt storage engine. We'll start with the two threads that I just spoke about, the sweeper and the compactor, here bottom right. As you can see, the compactor only actually reads and writes the data logs. The sweeper, on the other hand, reads from the transaction logs and uses these caching systems then to do its job. The user threads here are actually the connection threads of MySQL. They do the job in the transaction in the engine, and obviously they write the transaction log and everything else through these two caching systems. So I have in the middle here two types of caches. The one is a row cache, and this cache is capable of containing variable length records, and is responsible for caching the handled data file only at the moment. It could also cache data from the data log, but I don't do that yet. And then there's a fixed block cache, the index cache, which is responsible for those files which are handled in fixed blocks, currently 2K blocks, and that's the XDR and the XDR file, the index file. So moving on to implementation, I identify four phases in the development of engines. I've got until, I've still got over an hour, half an hour. So the four phases, at least in the development of pbxt, starting when you're implementing a storage engine, you start by implementing a sequential read and insert, update, and delete. And this is a very relatively straightforward. You don't have to understand much other than the actual internal record structure of MySQL. My tip for anybody thinking of developing an engine is to stop right there, because you've actually got a full implementation of a storage engine. And the rest is going to get a little bit more difficult. So, but if you insist on carrying on, then the next phase would be implementation of indexes. And this is a bit more tricky because you now got to understand how search keys work, key structures in MySQL, how the data types work, how they're compared, that kind of stuff. My tip for you is to make sure that you understand the various modes and flags in indexing, because there's a lot of them. If you don't get them right, it's not going to work. So there's stuff like prefix and exact matching, stuff like search first, search last, before and after positioning of a key, and they're all got to be implemented for things to work correctly. And the phase 3, if you want to continue beyond MyExam stage, then you'll implement transactions. And now this is even more difficult because none of this stuff is really documented, and it requires real code reading of MySQL. And my tip here is, I didn't do this immediately, so it really is a tip. Trace the API calls. So build yourself a good trace for the API calls and just check what is MySQL doing, which calls is it making when, and then use those calls to map to your transactional system so your functions get called at the right time. So there's actually a phase 4, at least there was for pbxt, that was the implementation of foreign keys. Now this is really not for the faint-hearted because it involves parsing SQL currently. And you have to implement your own data dictionary in the engine. And for some engines that's not a problem. The ones that are already existing all have their own data dictionary, but pbxt, being written just for MySQL, didn't have a data dictionary. And so I had to create one in order to finish this implementation. So my tip is actually, if you can, then wait for the MySQL guys to do this for you. We just didn't want to wait. Gotchas. So gotchas are wonderful things where you can spend hours contemplating, finding out how stupid you are and that you should have actually known that. My tip is to search the pbxt code for the word gotcha, because after spending a number of hours, I took 5 or 10 minutes to try and document what went wrong and why. But just to give you a couple of examples, assuming we have a query like this, update where C1 based on an index, simple index update. Now what you've got to know is that MySQL uses one table handler in this case, so it's using a table handler to search the index. The same table handler is going to be used to update the record, which in turn will update the index. So if you're caching an index block in your table handler, make sure you've got two buffers, one for reading and one for writing. Otherwise you have strange effects. But that one crashes. And then also a bit of a surprise, two keys of different lengths, but they can still be equal. And that's because of the effect that you get when ignoring trailing spaces for a key. So you can't just do a simple comparison to check for equality, a simple mem compare to check for equality. Okay, and this is one that got me because it was at some stage then possible to compile the engine completely independently of MySQL, and of course I mixed up the flags at some stage, didn't notice. The problem here is that it didn't crash, so it doesn't necessarily crash if you use the wrong flag. So I spent a few hours searching for a missing row, only to find out it was actually due to a compile flag. Strange effect. So, what are my experiences with testing? Basically, testing, very important. It's easy enough to test a storage engine. You can just start MySQL test run with standard test script runner and set your engine as the default, and what you get then is every test that runs with MyExam by default will run on your engine. So let's just look at some statistics of the testing. There's currently about 612 tests in the current 5.1 version. I counted the lines, it's almost 140,000 lines of tests, which is pretty good. So you're getting pretty good coverage there. In order to get these tests to run with pbxt, I had to modify just a bit over 500 lines of those tests. So that doesn't sound like a lot. But on the other hand, I had to modify 200 of the result scripts to get the tests to verify. But what I found is even with that small amount of tests and with the number of changes that are happening at each release to the test scripts, because every time a bug occurs, the test's got to be in, good policy, but it's causing a terrible integration problem for me each time a new release is there. And it can be a couple of weeks before I'm up and running again, and that's just not acceptable in the long run. So two questions we want to answer here is, well, why are there any differences at all? I'll give an example of that. And I want to propose something that will make integration a little bit more easier and basically testing for engine developers, and I think this is going to become a more and more important theme as we go on with more and more engines. How can we ease the testing for engine developers? I have a proposition there. So let's just look at one example of why there's a difference. I call this the select order problem. Some people are not aware of this problem. What it is that there's actually a difference in the natural select order between pbxt and MyExam, and probably as well a bunch of other engines. So if we just look at a simple example, this create table here, I create a table with two columns and insert two rows, 1, 1 and 2, 2. And then I update the first row, setting the second column to 3. Is that a question?
No, I have a solution for all your problems.
You know the solution before they even know the problem. That's not fair. Let me get to the end and then tell me, okay? So if I do that, then I'm going to get obviously what you see there, the result in the select 1, 3 and 2, 2. But if I do the exact same with pbxt, I get the result 2, 2 and 1, 3. So if you heard what I said earlier, then you'll know why that's the case. Basically, pbxt never updates in place, so an update creates a new record at the end of the data file and deletes the old data file, so you've got the natural order reversed. So what's your solution? Here's mine. Monty.
Actually, it's my test time, my test. We're just working on a patch that we basically do that.
Basically do something like this, sort the results in MySQL test run.
If you detect that we are not using a quarter by selecting that basically automatically, then it does the comparison with the test.
Fantastic. That's going to save me a lot of sweat.
Just to change the select by having order by.
Yes, you can add order bys to the test. Yeah, but Monty doesn't like that.
I have a very good reason.
Okay.
Optimizer takes things totally different.
That's correct, yeah. It's a completely different test after you've changed that, but I've had to do, that's a lot of those 500 changes I made were putting order bys in, a lot of them. Okay. So, Monty, I'm glad you're standing there because here's my proposition for modifications to MySQL test run, which will help us storage developers. At least it'll help me, I don't know, maybe. We'll hear from the other storage developers in a minute. Okay, basically we're going to have two types of tests, generic tests and then engine-specific tests. So when you start MySQL test run, you give it a list of the engines that it's supposed to test, and what it'll do for each engine, it'll run the generic test, and then if there are any engine-specific tests, it'll run that. So then, I would hope that MySQL would provide us a set of official results for the generic tests, which actually work with both MyISAM and InnoDB. Maybe the InnoDB stuff is not MySQL's problem, but hopefully we can have that as a starting point. And then what the developers can do is, if they've verified a test and it's still not, the result is still not the same as the official result, they can provide their own result, which will override the official result. So MySQL test run must check for an engine-specific result. And then the developer puts his engine-specific tests and his engine-specific results together into one file, and MySQL test run allows him to just drop that folder into the test run directory and automatically recognizes its presence when the engine is tested. And the advantages of this system, besides helping very much with the integration problem, is that it'll ensure a certain level of inter-engine operability, and it'll allow us as developers to contribute to the generic tests and just improve the number of engines that they run with, so we could submit patches then. Okay, so on to performance. Just some general comments about the performance tests and the performance so far of what we've seen. The performance tests have shown that pbxt is pretty good and covers quite a good wide range of queries in which it does well. And most of them have shown, in fact all of them as far as I know, have shown that pbxt scales very well. Also with the number of processors and number of threads. So it doesn't actually have any currently known issues with an 8-core machine, for example. Okay, significantly influeing the performance is the fact that pbxt doesn't have a clustering index. So this has disadvantages, but it also has advantages. The disadvantage is that ranges on the primary key can be comparatively slow because it's reading from the index and then from the data. The clustering situation doesn't have to do that, read twice, it just reads once. But it does make secondary indexes faster because it's not doing two index lookups. And for database administrators, it's also means that there's no penalty for creating a primary key which is more complex, so you're not restricted to sticking to integers and other small primary keys in order to get your performance from primary key lookups and secondary key lookups for that matter. Okay, performance tests have also shown that the pbxt responds very well to a fast disk. Conversely, you could say, okay, it responds badly to a slow disk. This is due to the fact that pbxt writes directly to the disk, so it transfers actually a lot of the concurrency problems directly to the disk subsystem. That also means that it benefits a lot from the amount of memory that is available to the OS cache. It also benefits from its own caching, but once the OS cache has got enough RAM, then I'd give the rest to pbxt itself. I'll configure it that way at the moment. So let me just say that if solid-state disks are the future of disks, then pbxt is ready for the future. And pbxt also achieves a very high data throughput, and we'll have a look at a graph in a moment. So just looking at the update performance, an example of a test with 1 million rows using sysbench 047, doing transactions with 3 updates, an insert and a delete on a 8-core machine. I get the following performance. And now this is with minimum durability on both engines. Just in case you're wondering about the transactions per second on the left. Okay, threads along the bottom. And comparing pbxt to InnoDB, you'll see that the InnoDB peaks somewhere between 24 and 32 threads and then drops off a bit. And also has a strange behavior that at 2 threads, it actually drops in performance. And as you can see, pbxt goes straight up to the maximum transactions per second and pretty much holds that all the way through 60 threads. Let's look at the data throughput. What I'm looking at here is measuring the throughput in bytes per second. So I take the, here's the graph first of all. I compared MyExam, pbxt and InnoDB. And down the bottom is the row size that I'm transferring, the actual packet size of the insert that I'm doing, starting at 128 bytes and going through to 1 megabyte. And on the left-hand side, you'll see the throughput in millions of bytes per second. And so here you'll see that the pbxt tracks pretty much the performance of MyExam, which I'd say from the design is kind of expected. So the engine's part weighs somewhere around 1.5K. So at about rows of about 1.5Ks, the performance of InnoDB starts to flatten out. And MyExam and pbxt both go up probably to more or less the maximum throughput of the disk. So that's probably the limiting factor more than anything else there. But I'm very proud of the fact that on this graph you can see that pbxt performance is actually very stable.
And that's the recovery after crash enabled as well?
No, that's also without durability. Recovery is always done. Okay. So,
okay. So does this mean like if the machine got reset, then you don't have to wait for the check table?
No, that wouldn't be the case. You'd have to do a check table. Okay, so what are our plans for the future? So my plan is that, well, the slide is old already. I thought it would be third quarter, but maybe it's fourth. My plan is basically to do GA simultaneously with the GA release of 5.1. The development is at that stage, which I think that's definitely doable by the third quarter. Doesn't really make sense for me to do GA of pbxt before 5.1 because that's really the vehicle. So still important for the GA release for me would be to get in various other durability modes. Currently, the durability mode can best be compared with InnoDB flush log transaction commit equal 2, which basically means InnoDB writes to the disk but doesn't sync. So that's the closest comparison, but it's not identical, as Peter pointed out to me, but he's right. Okay, so also on my to-do list a bunch of interesting stuff. Two-phase commit support. Select for update is also important. I found out yesterday how Falcon is doing it, so I can do it like that. That's the easiest way. More difficult way, they're locking the rows. More difficult way would be to lock the ranges. But if that's good for them, it's good for me. Index prefix compression will do quite a bit for pbxt. And then an easy thing for me to implement would be splitting of file over various disks, which could do a lot for performance. I'd also like to be able to split the blob data onto another disk, which would mean for me moving the data logs onto another disk. So I'm hoping they'll add a keyword, create table, and set the blob directory to something else. That might be relevant for other engines. And then I now want to talk a little bit about a new project. Yes?
For the blob, you really direct that you don't need a file. Because for data index, I just split different disks and keep the same file.
Yeah.
The
now you missed the beginning part of the talk where I talked about how pbxt has split the stuff up. I think, is that what you mean? Yeah. Yeah, pbxt has it split up so that it is in a separate file, so it can move the stuff around. Okay, so
another question. Are you
yeah.
planning to support online backup?
Online backup actually works already, and that's through the normal facilities of the MVCC, which pbxt supports. Because
you're supporting the MySQL interface being developed.
Yes, I will. That's important. Yeah, so that the backup can be coordinated with other engines. That's the reason why you want to support that API, and that's very important. Yeah. It's not a very complex API, so I don't think it'll be that much work. Okay, so I think most of you weren't at the BlobStream BOF last night, where we covered all of this information in a lot of depth. I'm not going to do it in quite that much depth, but I'd like to just tell you what the outlines of this new project are. So our goals for this project is, well, to state the obvious, to store blobs of any size in the database. And as you know, MySQL can already store blobs in the database, but there are certain limitations, like the blob has to reside in memory, and you've got to set the buffer, the receive buffer size or the packet size, so that it'll all work. I'm talking about blobs really of any size, megabytes, gigabytes, and so on. So we want to do this by streaming those blobs directly in and out of the database. And the objective is to create a scalable backend that can handle any kind of throughput requirements. So scalability is also very important for our customers. And we want to provide an open system which will support any engine. So the system that we're providing is just transporting blobs, it's not actually storing the blobs. The blobs will still be stored with the engines. And we want to provide a standardized client API which one will recognize whether one's using PHP or Ruby or whatever for the blob streaming. And this will be an extension then to the standard MySQL client API. An extension, it won't be in the same library, it will be additional library, but it will extend the existing API. We want to do this with minimal or no changes to the actual MySQL code base, and I'm not saying this because we don't have support for MySQL. In fact, we've got overwhelming support for this project from MySQL. It's just a matter of release schedules. So we want to have something for our customers by the end of the year on this, and that would be with 5.1, and 5.1 is pretty frozen right now, so can't really expect MySQL to roll that back for us. And of course we want to design a system that's going to meet a broad range of customer needs, and we know what our customers need, but we don't know what all of your customers need. Or so please contact me if you're interested in this technology. We're really in the forming stage now, so just about anything's possible. We can talk about design, whatever. And I put up the website address there, blobstreaming.org. We're going to start a forum there as well, but the information that I'm giving here and other area, all other information will be available there. Okay, I think I've got 15 minutes still.
Yes.
Yeah.
13.
Pardon?
13.
I've got 30.
13.
13. Okay, let's just run through the advantages. Most of you probably know this, but I know there's a debate about this, so let's just look at the advantages. First of all, storing the blob in the database, you have an atomic operation, so you don't have a problem with references that get lost or are dangling and the blob's gone. The blobs that you store in the database will be subject to the backup, and I actually just discussed with Lars this morning how that would be possible for the streaming blobs to fit into the new MySQL backup scheme, and we see actually no problem there at all. And this is important for our customers. Blobs must be able. One must be able to replicate the streaming blobs. Obviously, if you're storing your blobs as files in the file system, then the replication system knows nothing about that. But this particular stuff, that'll require real work on the part of MySQL. I'm willing to help, obviously, if they'll accept my patches, then we're in business. Okay, and then finally, if you're storing blobs in a file system, and we have quite a bit of experience with this, you're going up to 1-2 million files in a file system, then things start to get really slow under circumstances unless you've got some sort of specialized filing system. And the engine storing the blobs need to solve this problem. Okay, so if it still remains a problem, then you speak to the engine developer. And this is an overview then of our blob streaming architecture. I'll point out the most important components. Here we have a connection which is running in parallel to the standard MySQL client-server connection. This is a stream-based protocol, and this is the protocol connection that's actually transporting and streaming the blobs. So we're talking about, okay, you could call it a backdoor, and this is the blob streaming engine. That doesn't mean it's going to be implemented as an engine, but it's a component which is plugged into MySQL either through the engine API or the daemon API, which is the backend for the blob streaming. And this component will provide an API for those engines that want to be blob streaming enabled. And this is the client component, which is the extension to the existing MySQL component. So basically, this kind of architecture allows us to add this functionality to MySQL quite efficiently, I think. And an interesting point is it's most likely that this stream-based protocol, I'm saying 99.9% sure that I'm going to use HTTP for this stream-based protocol. So we're talking about streaming the blobs from the disk here over this protocol under circumstances all the way into your browser without being buffered anywhere in between. Right, these are the most important links. And yeah, and then any questions? We've got 9 minutes. Yes?
On a garbage collector thread,
Yeah.
does that mean that your storage requirement has to support import the biggest log file that you have for variable data to be able to clean up that?
Okay, the question is about the storage requirements of the garbage collection. They're pretty demanding, they're pretty high, yes, because when I collect, I have to create, first of all, a completely new data log, copy everything, so at that point, I'm actually increasing the requirement by 50% before I can reclaim all of the stuff. So, and then depending on how you're setting your garbage threshold, you're also requiring a lot of additional space because you're keeping actually around a lot of garbage until the compactor actually kicks in. And if, for example, for some reason the garbage collector is not running, it's low priority, so there's a lot of activity on the database, and you only have a single processor or whatever, so it's not running, then of course it's not going to do its job, or it's going to do its job pretty slowly, and you need enough disk space then to overcome your peak times, your peak access times under those circumstances. Yeah.
I have a question about the garbage collector. Do you have any throttling done for it?
Do I have any what?
Well, you mentioned it's a low priority thread, but for most operation systems, the thread priority doesn't affect the disk scheduler. And that stuff, as I understand, will be mostly doing disk schedule.
So are you saying that there could be a problem on systems which don't support low priority threads?
Well, yeah, but low priority threads, the thread priority quite typically does impact IO request priority. Okay,
yeah. Okay, so the comment here is that even if I set the thread to low priority, that doesn't affect the priority of the disk I/O that it's doing. So the disk I/O is obviously going to affect what the foreground processes are also trying to do on the disk, right?
Yeah,
that could well be the case.
Yeah. So you don't have so far any throttling. What I mean is, to say, okay, just do it in, in some. Let's say, do some compression, wait for a few milliseconds or something.
I have no. Other than the fact that I've made it low priority, I have at this stage, no further control over when compaction is done and so on.
The way you get like a budget for NDB is rate limited. So if you've written this many bytes of data, you just sleep until the next time period.
That would be a simple thing to implement. A write limit suggestion is to just write a certain amount of data and then sleep after that. You'd probably have to couple that with a some sort of a, but if the disk starts getting full, then start getting a little bit more desperate.
Why won't you?
Back over there.
Can the collector impact more than one table at once, or is it possible to get into a situation where there's so many updates on so many tables that the collector just never catches up and just keeps up?
Is it possible that the collector can get so far behind that your garbage starts piling up into ad infinitum? I suppose that is a possibility, yes. This sweeper and the compactor, there's one per database. Just want to mention that, didn't say that there. So every single database has its own sweeper, own compactor, own transaction logs, completely isolated from others. Is it a related question?
Somewhat.
Okay.
Are you using information scheme to display the development state of how many holes, how much garbage, what's the state?
Oh, that would be a brilliant thing. You want to implement it for me?
I would.
Great. No, the question is, am I using information schema to display the status of the data logs, how many holes, how much garbage, rate of collection? That would be great, of course, because that will allow you to predict if you're going to have a problem in a certain time, whether you have to install a new disk or whether you have to add another processor so that the garbage collector can work a little bit faster, for example. That one, you were first, yes?
Me. Okay. You had the compactor running. If I understood it right, you have fixed length records in one file, right?
Yeah.
Are you running the compactor on them?
No, the compactor only works on the data log files which contain the variable length data. So the management of the fixed block files is really done quite simplistically. I have a free list, and when a block is deleted, I just add it to the free list, and when I need to allocate one, I first look to the free list, and only if it's empty, then do I add another record to the end.
That will solve your problems if you have records all over the
So the question is, can that cause problems with I/O because it's scattering the records all over the disk? Yeah, definitely it can. But what you'd actually have to do then is to avoid this problem, because any system which doesn't specifically do something about that is going to have that kind of problem. No matter how you manage your data, it's going to get scattered, it's going to get mixed up, and even if it's ordered, you might access the data in a completely different manner, so that can always happen. What you've got to do then to fix that is to actually examine how the data is being accessed and try and move the records around so that they're more together, and then you do get better I/O performance. You definitely then get better I/O performance, and that could be done in pbxt. You'd have to adjust the index where they're pointing. You'd have to lock the row that you're doing that on. It could be done by another thread, independently of the system. Giuseppe.
In which of these addresses are the slides?
In which? None of them yet.
Okay.
Okay, just a question, where would I post the slides? I'll post it, I've done that up until now under the /xt address. Yeah.
Are you posting them also in the standard mysqlconf.com or what?
Sorry?
Are you going to post
They post them. O'Reilly posts them there, yeah.
O'Reilly?
Oh, does
They take
O'Reilly
care of
post
that.
them as well?
O'Reilly,
Okay, they've got to ask me for it because I haven't given them that.
But,
Oh, but you've got a copy anyway, so I suppose I wouldn't know.
you actually mentioned like the logs per database. So what's about the cross-database transactions?
That would have to be, cross-database transactions would require XA.
Yeah, and what is about the visibility? Like if you start, because XA defines commit order, but what about consistent reads for cross-database?
So what about consistent reads across databases?
Yeah.
Can't do. Can't do at the moment. Okay. Yes?
How do you determine the length of the fixed rows? Is that based
Yeah,
on
that's-
a hard-coded thing?
No, that's a very good question. The length of that fixed length component is fixed per table. It's not fixed overall, it's fixed per table. And what I try to do there, and I'm sure there's a lot of much better algorithms, is try and estimate what the average row will be sort of for the fixed length data if you're not writing more than, say, 100 bytes or so for any variable length field. So what I try to do is get a measure of things so that I'm going to put actually most of the rows that you're creating into the fixed record. And that's just an edge. Actually, what one should probably do is analyze the table. Well, in analyze table, you could actually then, I'll be with him, and then get an average, and when you rebuild the table, then have a better fixed size record. That would be possible. Monty?
If you use average row length option to create table, you use that for a fixed size.
You think that's a good estimate?
That's for a user to decide. You can use that as something, let the user give you a hint.
Yeah. Okay, I'm calculating myself. I don't know. Yeah, but there is an average row length. Yeah, already available. Stu.
So, Michael Rostrom has a patch that will come in at some point that enables per field specification of storage. So you could possibly use that as well. So with NGB, you can say per field with a memory or disk. So you can probably use that as well, whether it's in the fixed or bioscience if people choose.
You better explain that to me again. I'm getting distracted now, and I think, maybe you guys can come forward and ask me then because time's up. Thanks very much.